Feature Engineering Basics in Python. Welcome! In this lesson, we will explore how feature engineering helps machines learn from data. We will use simple Python code you can run, change, and play with. Feature engineering means creating or changing data, so it is more useful for analysis or machine learning. Let us get started and see why this is so important. Running the cell now. What is feature engineering? Think of feature engineering as giving the computer better clues. We take raw data and turn it into new shapes and forms. This helps computer programs learn faster and make better decisions. Running the cell now. We will begin by creating a simple list of ages. This is a comment to say what the next line does. We are storing a small group of ages in a list. Another comment about what happens next. We print out the original ages, so we can see the starting data. Running the cell now. Try changing a number in the list and running it again. Practice helps you remember. Now let us create a new feature called is_adult. This tells us if each age belongs to an adult or not. We are explaining what we will create here. Let us use code comments to remember our steps. We begin with an empty list to store our new feature. We use a loop to check every age. If the age is at least 18, we mark that person as an adult. We record this with true. If not, we record it as false. Finally, we print out our new list that tells us who is an adult. Running the cell now. Pause to add your own age and check the result. Why create new features? Often, original data does not give us all the clues we need. By adding new features, we help the computer find patterns and make smarter choices. This is like giving someone better hints to solve a puzzle. Running the cell now. Let us combine names, ages, and the new adult feature together. We are labeling this part with a comment. We create a simple list of names for each person. We use a special tool called zip, which walks through all three lists at once. It prints every person's name, age, and shows whether they are an adult. Running the cell now. Try adding your own name and age. See how it changes the output. Sometimes our features come from text. Let us see how often a fruit appears. We begin by adding a helpful comment to explain our goal. We make a list of favorite fruits. This comment explains what we will do next. We use a built-in count method to see how many apples there are. We print the total number of apples found in our list. Running the cell now. Try counting how many times banana appears instead. Real datasets are often missing values. Let us fill in those gaps with a safe guess. We use a comment to remind ourselves what this cell is about. Another reminder that filling missing data is important. We have a list that includes none values. None means missing. We make a new empty list to store changed ages. We loop through each age. If the age is missing, we fill it in with 18. We choose 18 as a safe guess for someone who is just becoming an adult. If age is already present, we keep the original value. We print out the new list with no missing ages. Running the cell now. Change the default age to a different number. What happens? Computers like numbers. So we often turn text into numbers, called encoding. We use a comment to say we are working with categories. This comment reminds us why we do this. We make a simple lookup table matching fruit names to numbers. We start an empty list for the results. We loop over each fruit and add its number to our new list. We print out the list of fruits as numbers. Running the cell now. Change the mapping. Try making a banana equal to 5 instead. We can create new information by comparing values. Let us see how far each age is from the oldest. We write a quick reminder with this comment. This comment shows that math is very helpful for feature engineering. We find the largest age in our data. We use a list comprehension to calculate the difference for everyone. We print out the result so we can see each person's gap from the oldest person. Running the cell now. Try printing out the oldest age as well. Making features more useful. Sometimes, features work better when scaled down or changed. For example, big numbers can be harder for computer models to use. Let us normalize our ages so they fit between 0 and 1. Running the cell now. Let us turn ages into numbers between 0 and 1. This helps computers see all values on the same scale. A quick comment to remember what this step does. We find the smallest age. We find the largest age too. We create an empty list to hold normalized results. We loop through each age. We use a simple formula to get a normalized number. We add it to the new list. We print the list to see the scaled values. Running the cell now. Try changing the ages list to see how normalization changes the results. Now, let us create a feature that shows age per sibling. This is useful for spotting ratios. We add a friendly comment about our intent. Here is a list of siblings for each person. We introduce our feature, age per sibling. We loop through the ages and number of siblings together. If the person has 0 siblings, we just add the age. Otherwise, we use integer division of age by siblings to get a whole number result. We print the new list, showing this new feature. Running the cell now. Add more to the siblings list and see what happens. Bad or strange data can trick our models. Let us remove obvious outliers. We note that sometimes we need to delete rare or impossible values. Here is a list that includes a likely error, 201 years old. We start a new list for values that we trust. For each age, we only keep those that make sense. If the age is less than 120, we add it. Otherwise, we skip it. We print the cleaned list. Now our feature is more trustworthy. Running the cell now. Try adding a negative number to the list. What should be done? We can mix features to help computers spot new patterns. Let us glue numbers together as text. Here we mention the idea of combining features in a comment. Another comment explains exactly what features we will mix. We make an empty list to store the result. We loop over ages and siblings together. We join the values and some text to label the sibling count. We add the new string to our feature list. We print out these combined clues. Running the cell now. Try changing the separator from _sib_ to dash or another symbol. Too many features can slow down computers. Let us pick just what we need. Feature selection means we focus on important clues. We put several features in a dictionary, which is a group like a labeled folder. We start an empty folder for the ones we want. We look through each feature. If it is not siblings, we keep it in our selection. We print out the features we have chosen. Less can be more. Running the cell now. Try including or removing other features. See what happens. Sometimes data comes from user input. Let us try asking for your city. This comment shows what we will do. This asks the user for their city using input. Input means you type something in. We print out the city you entered. Running the cell now. Try entering a city name from a different country. Let us practice feature creation by making a list with your favorite animal. We set up a practice comment. This asks you for your favorite animal. We create a new feature by repeating your answer for each name in our list. We print the finished list. Running the cell now. Practice makes perfect. Try changing the animal and count how many there are in the list. Now it is time for our mini project. Let us make a small list of students with a few details. We label this as the first piece of our project. We start building our actual dataset as a list of dictionaries. Each row holds a student's details. This row holds another student's details. And another student's info. Here is our last example student. Now we loop over our students. We print out each set of details to see our start. Running the cell now. Can you add a new student to this list? Try it now before we move on. If you are learning, remember to like, subscribe, and share the YouTube video to support us. Now let us add 2 new features, whether each student is an adult and if they passed. We note this as part 2 of our mini project. We loop over each student and add a true or false for being an adult. We add passed as true if their score is at least 80. Now we print each student with the new features added. Running the cell now. Try changing the passing score to something higher. How does it change your list? Let us get just the students who are both adults and passed. Filtering is a key feature engineering skill. We say in a comment what is about to happen. We make an empty list for our answer. We check all our students. If both is_adult and a passed are true, we keep their name. We print out the adults who passed. Running the cell now. Practice, can you filter for students from a certain city instead? Let us sort students by their test scores. Sorting can make patterns easier to see. A reminder that sorting is common in feature work. We sort the student data from the best score to the lowest. We print out each name with their score, in sorted order. Running the cell now. What happens if you sort by age instead of score? When datasets have many features, it helps to print them out. Let us see which features we have. This comment describes what we are doing. We show all the available features as a list, using keys from the student's dictionary. Running the cell now. Try this for a different student or add your own features and see the difference. Recap, what did we learn? We saw how new features help computers understand data. We made and changed features using math, logic, and even input data. Practice these skills to help any dataset shine. Running the cell now. You made it. Want to keep learning? Like this lesson? Please hit like, leave a comment, and subscribe for more easy Python videos. Share this with friends who want to level up their Python skills. Thank you, and see you in the next video. Running the cell now.